Okay, so in this video, I'm going to work I'm not going to do 25, 27, 29. I'm going to do 25, 27, and 28. No, 26. 25, 26, 27, and then I'll pick back up with the odds. So 25. 25 says, state the number of possible triangles that can be formed using the given measurements. So I've got angle B equals 54 degrees. Side A equals 30 centimeters and side B equals 27 centimeters. So here's what I know. I'm always going to create the angle. If they're given a situation like this, it's always going to be an angle and two side lengths, right? So what I'm going to do is I'm going to create an angle, 54 degree angle. So 90, 45's in here, so 54, somewhere in here. So that is going to be angle B, which means I've got two side lengths, A and B. B would have to be across the 54 degrees, right? So somewhere over here. So I'm going to let A be 30 centimeters. Okay, so I've got a length of 27 centimeters, right? So what I know is that it's definitely shorter than the 30, right? My question is it too short? And I think it's going to be okay. I need to find the height, and then I can figure out where 27 lands in relation to that, okay? So I'm going to set up my sine to find height. Sine of 54 degrees equals height over 30. Sine of an angle equals opposite of a hypotenuse, and that creates that right triangle. So 30 times sine of 54. 30 times sine of 54 is 24, so the height is 24.271. 24.271. So if I think about the length 27, 27 for B is longer than the height, so it definitely creates a triangle, right? If it was too short, if it was shorter than this, it wouldn't create one, and it's not the exact same length. It's a little bit longer, but it's shorter than 30. So 27 is going to land somewhere in here, and that is a length that is between the height and 30, which means it could swing and create two different triangles, okay? So because 27 is greater than the height, but less than 30, then I've got two triangles. Okay, so there's 25. Now I'm going to do 26. So 26 says, I don't know why I went, no, whatever, doesn't matter. Measure of angle A, that was awkward, is 98 degrees, which is obtuse, that's kind of interesting. C equals 34 centimeters, and A equals 34 feet. I don't know why I said centimeters. 34 feet, not that that matters. And A equals 34 feet. Okay, so I'm going to make a 98 degree angle, which here's my horizontal, and then here's 90, right? So 98 is a little bit past the vertical, so I'm going to do something like this. Okay, so here's 98 degrees. Now, this being obtuse makes this whole thing kind of obsolete. I have a new set of criteria if I have an obtuse angle. So let's talk about that over here. Let's just do a general thing. So say I have an obtuse angle. I'm going to exaggerate a little bit, okay? And whatever this length is, right? Whatever this length is, if I have to include this angle, then it has to be a length over here to create my triangle, right? There is no swing side to side. It's either it creates a triangle or it doesn't, right? So here's the thing. If it's shorter than this length right here, if it's shorter than this, then that means if I hang it from here, it will just dangle over here. It will not be able to reach the horizontal on this side, right? Even if it was exact same length as the height, it doesn't matter. Even if it was this length, if it was this length, that's too short to include this angle and reach this side of this angle from here, right? So, okay, so shorter than this length is out. Doesn't make a triangle. What about if it's exact same length? Well, if it's the exact same length, then it would just come back. So I would go out here, and then I would have to come right back, and I would not include this angle at all. It's not a triangle. So here's the thing. If I have an obtuse angle, then the side length coming off of here has to be larger than this length right here in order to create a triangle with this obtuse side, or this obtuse angle. And keep in mind, If you have an obtuse angle, then the side opposite that obtuse angle must be the longest side in the triangle, right? So if I have an obtuse angle, that must be the longest side. So if I have anything shorter or the same length as this side right here, it won't work. It's got to be this one. I shook my head no like y'all can see that. Alright, so let's talk about this right here. I've got C being 34 feet, and so since this is A, angle A, C has to be the one next to it, adjacent to it. Because A has to be opposite it, right? So 34 feet. So now, that is so messy. 34 feet. Okay. Now, it says A is 34 feet. Okay. If I go from here, like I create this right here, and I go out 34 feet, and then my other side length is 34 feet, if I try and do that, it go from here to this horizontal and this side of it, right, it would just come straight back down, and it would not create a triangle. So, I have no triangle. Or 0 triangles. Yeah? I would have had one triangle if A had been greater than C. If A had been greater than C, so this is side length C, if A had been 38, you know, if it had been 40, if it had been 50, whatever, if it had been longer, then that would have made sense, because having a 98 degree angle means it needs to be across from the longest side. And these two side lengths were the same. Well, I can't have two 98 degree angles in a triangle. That doesn't make a triangle. So, no triangles. That's why I wanted to do 26 with you. Alright, let's talk about 27. So 27 gives me the measure of angle C as 88 degrees, and then it says C equals 16 kilometers and B equals 6 kilometers. Okay. So 27, I've got the measure of angle C is 88 degrees, side C is 16 kilometers, and side B is 6 kilometers. So here's what I've got. 88 degrees is really close to a vertical or an obtuse, but it's not quite. Whatever. Okay. So I'm going to exaggerate it a little bit so you can tell it's not a 90 degree angle or obtuse, but that's 88 degrees. Man, as far as finding the height, that would be kind of awkward here. So, glad we don't have to do it, because here's what I know. This is angle C, and side B is the one that has to be beside it, adjacent to it, right? Because C has to be opposite it. And here's what I've got. I've got angle C, which is 88 degrees, and I've got side B, which is 6 kilometers. And here's the thing. The other side length I'm given is side length C. That's 16. Yeah? Here's 14. Now imagine I had a length that was 10 units longer, 24. Well, 10 units longer than this would have to be somewhere way out here. Okay, so we're talking about this situation. The only way that I can fit a 16 kilometer going from here to this horizontal is if it swings way out here. And so that could be a 16 kilometer length compared to, sorry, you can't see it. That could be a 16 kilometer length compared to this length right here, 6. So since this is a situation where the side length that across from the angle, so the side length across from the angle is greater than the adjacent side length, if it's a lot longer, then it can only create one triangle. Okay? So that 16 is only going to create that one triangle because it's so much longer. Okay. Now I'm going to go to number 30. Let's see. Let me see this real quick. Okay. It says solve each triangle. 30 and 31. Okay. So I'm gonna discuss this right quick. 30 and 31. When it says solve the triangle, it means find all the other side lengths. But if you're given an angle and two sides, like you are in number 30, you must first assess whether or not you have 0, 1, 2, 0, 1, or 2 triangles, okay? If you only have one triangle, so it's the same length as the height. It's the same length as this side, or it's longer than this side. Then you're good. You only solve one triangle. Carry on. But if you find the height and your length across from your angle given is between the length of the height and this length, then it could be here, or it could swing and it could create another triangle here, in which case you have 2 triangles to solve, okay? I guess I don't like that I only have one of those, but tell you what, number 30 does have 2 triangles, okay? So I'm going to go ahead and write that down. 30 has 2 triangles. So I want you to be prepared to look for that. So when you solve the triangle, you're actually going to be solving the triangles. Okay, you're going to have 2 different triangles to solve, which means you're going to need angle A, angle B, and side A in triangle 1. And you're going to need angle A in triangle 2, angle B in triangle 2, and side A in triangle 2. Okay? So you're going to need to have 6 answers for number 30. Okay? I'm going to work number 31. If you need help with number 30, then let me know, okay? I think I have... No, I don't have a meter. Rude. Okay. Okay. Number 30. So solve the triangle, and it's got the measure of angle B equals 52 degrees. The measure of angle A is 111 degrees. And C equals 10 inches. And it says solve the triangle. So this is a little bit different in that I've got 2 different angles, and one of them is obtuse. Personally, I always like drawing the obtuse angle first, so I'm going to think about 111. So if I've got the horizontal and then here's 90, so 111 is somewhere in here. Okay. I'm going to let that be angle A, 111 degrees, and then I'm going to think about what side length I have. I have C, which is 10 inches. Okay. Okay. I'm going to let this be side length. This is going to have to be side length C, which is going to be 10 inches. And then I'm going to let this be angle B. So it makes sense that angle A across from that is going to be side A, and then across from angle B is going to be side B. So side C is going to be over here, okay? Okay. So I need to draw an angle with 52 degrees. So I'm going to pretend like this is my horizontal right here, right? And I'm going to go 52 degrees. So here's 90, here's 45, 52 is somewhere in here. So I'm going to go like here. But remember, it's got to meet this right here to create that 111 side length, right? So I'm going to stop myself from curving, although I think I am. Just my instinct is to bow down, but it doesn't do that. Okay. Now, if you drew just an acute triangle, bump, 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 and then just label the side lengths, then you could figure, like you could find it, whatever. But it makes better sense for me to think, let me draw my obtuse. Let me draw, so this is going to be my set length of 10 inches, and then let me draw this angle at 52 degrees, and then I'm going to have to make it meet this side length over here. I think I still bowed down a little bit. Alright, so here we go. This is going to be side A, I need it. This is going to be side B, I need it. And this is going to be angle C, which I need. Okay. I have an angle, I don't have an angle and a side pair. I do have an angle and a side pair because I can find angle C. I know 111 plus 52 is 162, and 180 minus 162 is 18 degrees. So this right here is going to be 18 degrees. No. I did 110, not 111. That's rude. That's 163 degrees, which means this is going to be 17 degrees. Cute. Okay. So I've got an angle and a side pair, and then I've got an angle and I need a side. I've got an angle and I need a side. So I'm going to do law of sines, and it looks like I'm going to do it twice. So I'm going to solve for side A. Remember, I always said if I want to solve for a side length, I put it on the top using law of sines. If I want to solve for an angle, I put that on the top, sine of the angle. As it is, I want to solve for A, so A divided by the sine of angle A, 111, equals, and I'm going to use the angle and side length I know. So side length on top, so 10, and sine of the angle on bottom, sine of 17 degrees. I'm trying to solve for side A, so I'm going to multiply by sine of 111. So 10 sine of 111, 10 times sine of 111, divided by sine of 52, sine of 17, just kidding, sine of 17. And I get 31.931, and that just solved for side A. 31.931, and that's going to be in inches. Yeah? So side A, 31.931 inches. And let's see if that makes sense. 17 degree angle got a length of 10, 111 got 31.931. That does make sense, and this needs to be quite a bit longer than that one right there. And it looks like it could definitely be 3 times that length right there. Okay, now we're going to solve for side B. B divided by sine of its angle, sine of 52, equals, and then I'm going to use the side and angle pair that I had before, sine of 10 divided by sine of 17 degrees. Okay, so again I'm going to multiply by sine of 52 on top, 10 times sine of 52, so 10 times sine of 52 divided by sine of 17, and I get 26.952. So 26.952. 26.952 inches. And that makes sense in the grand scheme of things. Let me see. What did I work that was 17 degrees? Okay. So as far as my answer goes, 111 got 31.931, 52 got 26.952, and 17 degrees got 10 inches. This will not work with the Pythagorean theorem because it's not a right triangle. So you have to use law of sines, use your angle and side pair that you've got. And there we go. 30. 1. 31 is what I just worked. Okay, so there's 31. Now let's go to number 33. Number 33 says find the measure of angle C given this situation right here. Kind of looks like an isosceles triangle, but it's not quite. I've got angle A, angle B, angle C, and that's what we're trying to find. I've got 68 degrees right here. I've got 30 feet right here, and I've got 24 feet right there. Okay, so here's the thing. I only have one angle, so I can't find the other two angles unless I use one of the law sines or cosines. And I don't have an angle and a side pair. I have angle B, I don't have side B. I have side A, but I don't have angle A, and I have side C, but I don't have angle C. So law of sines is out, which means I have to do law of cosines. Law of cosines, just as a reminder. And I'm going to use A as the normal because it doesn't matter, and then I'll readjust it to what we need. A squared equals B squared plus C squared minus 2BC times the cosine of angle A, or side A equals the square root of all that, right? A equals the square root of all that. What I want to do is I want to use this to solve for, think about what I know, okay? This solves for side length A, knowing angle A, and then the other two side lengths, right? Well, I know angle B, and I know side A and side C, side A and side C, right? So I'm going to replace A with B. b equals the square root of the other two side squared, so a squared plus c squared, minus 2 times the other two sides again, a times c, times the cosine of the angle of the side right here, cosine of angle b. So, b equals the square root. And I know, okay, fact of the matter is that law of cosines, this is the only thing I can solve for first, is this side length. But once I do that, then I've got an angle and a side pair. I can either do law of cosines again to solve for c, because I'll know these two sides, and that side. I'll do it both ways. I'll do that in a second. So side b equals side a squared plus side c squared minus 2 times side a times side c times the cosine of the included angle b, 68 degrees. Okay, so I'm going to type that in. The square root of 24 squared plus 30 squared minus 2 times 24 times 30 times the cosine of 68. And I get that side B is 30.603 feet long. 30.603. Okay, so knowing this, I can either do angle side pair, angle side, and solve for angle C. So I'm going to try that using law of sines. I want to solve for angle C, so sine of C over the side length for C equals, and so if it's angle on top, then it's angle on top, sine of 68 over side B, 30.603. So that's one option. Couldn't even read what I was writing. So sine of angle C over 30 equals sine of 68 over 30.603. So now I have enough for law of cosines or sines because I have an angle and a side pair. I can also solve for angle C if I use this law of cosines formula. I'm going to rewrite it though. If I want to solve for angle C, the only way I'm going to get an angle in there is if it's this one. So if this is C, then that's C, and that's A and B. Okay? So I'm just going to write that out for a second. C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Okay? If I were to fill this in, C is 30, so 30 squared. A is 24, so 24 squared. B is 30.603 squared, minus 2 times A again, 24, times C again, 30.603, times the cosine of angle C, and there's my variable, right? If I want to solve for this, then all I would have to do is subtract 24 squared, subtract 30.603 squared. Okay, so I've subtracted those two, so they're gone, right? All of those are gone. And then I'm multiplying all of this together, right? Which means I would divide by everything except, well, the cosine of C can't be divided. So I'm just going to divide by negative 2 times 24 times 30.603. Okay, and then that all equals cosine of angle C, and so if I want to solve for C, then I would just take the cosine inverse of all of that. Okay? Not quite as cute as the law of sines. We're going to see if we get the same thing, okay? In this process, I'm going to multiply by 30 on both sides. So I get sine of angle C equals 30 sine of 68 degrees divided by 30.603. Dang, those are really, oh yeah, well no, they're close because it basically looks like a isosceles triangle. Okay, and then I'm going to take the sine inverse of both sides. Sine inverse, those two go away. C equals the sine inverse of all that. So I'm going to type it in. Sine inverse of 30 times sine of 68, 30 times sine of 68 divided by 30.603. And I get 65.356. So 65.356. Wow. 65.356 degrees. Okay, and that makes sense. If this is 68 and this is 30.603, 65.356 getting 30, it should be slightly smaller. Okay, pans out. I'm going to see if I get the same thing over here. So I'm going to take cosine inverse of all that crap. So cosine inverse, I'm going to use the alpha y equals and do the fraction. So 30 squared minus 24 squared minus 30.603 squared, all divided by negative 2 times 24 times 30.603, and I get, okay, so I don't get, oh, I forgot my 6. That's why I was like, dang, it's quite a bit off. Okay, I get 65.355 degrees. So the difference is a thousandth of a degree, which is understandable because I rounded to a thousandth of a degree. If I had gone like 5 decimals in 30.603, what was that? If I had used 30.60337 right here, 337 here, and here, then I would have been correct to the, that would have had the exact same to 1/1000th of a degree. As it is, I'm okay with that. I'm okay with that error. So there we go. Okay, I hope that made sense. So just as a reminder, in order to solve for angle C, I had to first use law of cosines to find this side length, and once I did that, I had an angle and a side pair, and I was able to use law of sines, or do law of cosines again, but this time solve for the angle, because I had the 2 side lengths. Actually, law of cosines to solve for an angle, you have to have all 3 side lengths in order to solve for the one angle. But anyway, there's 33. Alright. Let's do 35 uses Heron's formula, and that's pretty easy. So I think what I'm going to do is I'm going to do 36. I'm going to do Heron's formula as well, but I'm going to do, this 36 takes a little bit more work, so I'll do that for you. So I've got PRQ. I've got 13 meters. I've got 75 degrees. I've got 5 meters, and I'm supposed to find the area. Okay, so Heron's formula is actually pretty easy. If I, like, first you need the side length, right? Or S, not side length. So the side S is 1/2 the perimeter. So it'd be side R plus side P plus side Q. Yeah? And then what I'm going to do is I do the area equals the square root of S times S minus R times S minus P times S minus Q. And that is what that would equal. I don't have that formula written down, so I'm going to make sure, because I don't want to be wrong. That would be bad. Okay, good. Okay, just want to make sure it was 1/2 times that, because I hadn't seen it in a little bit. Alright, so here's the thing. In order to figure out the area using Heron's formula, I need all 3 side lengths. I have 2 side lengths. So I have 2 side lengths and the included angle, not an angle and a side pair. I don't have angle R and side R, or angle P and side P. I have angle R and then side P and side Q. So what I'm going to do is I'm going to do law of cosines to solve for side R. R equals the square root of P squared plus Q squared minus 2 times P times Q times the cosine of the included angle R, which is 75 degrees. So I just use law of cosines. That's my A, B, and C, if you will. And I'm going to type that in and I get R. And once I know R, then I can do Heron's formula with it. Okay? So the square root of 13 squared plus 5 squared minus 2 times 13 times 5 times the cosine of 75. I'm not even typing anything in. That's ridiculous. Okay. the square root. I hate that my lighting is so weird right now. I don't know what's going on. It's evening, whatever. 13 squared plus 5 squared minus 2 times 13 times 5 times the cosine of 75 degrees, and I get 12.663. 12.663. Which must mean that angle P is going to be larger than 75. Just a thought, but we're not having to solve this, so we're just finding the area. So I'm going to find S. S equals 1/2. R. I just put degrees on the side length. That's terrible. Don't tell anybody that. 12.663 plus P, which is 13, plus Q, which is 5. So 1/2 that, whatever that is. Okay, 12.663 plus 13 plus 5, and then divide all that by 2, and I get 15.3315. So 15.3315. I might as well use that whole number. 15.331. Well, I better like it. Whatever. I'm just going to write it down. Okay, so S times 15.3315 minus R, 12.663, times 15.3315, and I know I'm going off the page, but minus P, which is 13, times 15.3315 minus Q, which is 5. The square root of all that, and there we go. So, second square root. 15.3315. Yeah? Okay. Times 15.3315 minus 12.663. Close parentheses. Did I do parentheses? I did. Times 15.3315 minus 13 times 15.3315 minus 5. And we should get 31.392. Okay. 31.392. And that is the area. The side lengths were measured in meters, so that's going to be meters squared. Okay. Okay, I'm going to go ahead and do number 37, although I hope the video isn't getting too long. You know, I'm just going to do 37 on its own video, and then there you go.